Welcome back, and in this video we are going to look into the acromioclavicular joint in the shoulder complex. You know that the shoulder complex contains sternoclavicular, acromioclavicular, scapulothoracic and glenohumeral joints in particular. And we learned about the sternoclavicular joint anatomy as well as the sternoclavicular joint biomechanics in the previous. And now in this video we are going to learn about the acromioclavicular joint in detail. What is the type of the joint? What are the structures involved? What are the accessory structures? Does it have a disc or does it have a joint capsule which is strong? And what are the ligaments in the acromioclavicular joint? And finally the acromioclavicular motions. We will see motions in the next video, and this video we will focus up to the acromioclavicular joint ligament. Yes. What is acromioclavicular joint? The acromioclavicular joint is very simple to learn as compared to sternoclavicular or scapulothoracic joint or even the glenohumeral joint. It is having a very simple articulation with the acromion process of the which bone, that the scapula, with the lateral end of the clavicle. So this is an articulation between acromion process of scapula with the lateral end of clavicle. Okay, the medial end of the clavicle forms the sternoclavicular joint, and here we have the lateral end of the clavicle forming the acromioclavicular joint. So for your understanding, this is the acromioclavicular joint. Here is the clavicle, medial end of the clavicle, the lateral end of the clavicle. Clavicle is a horizontal bone, and you have the acromion process over here, and you have the which process here? The coracoid process over here. So this lateral end of the clavicle is going to articulate with this acromion process. This joint is known as the acromioclavicular joint. Okay, am I clear? So this lateral end of the clavicle simply articulates with the acromion process of the scapula and forms which joint? Acromioclavicular joint. Right? Now let us examine into the joint in detail. I told you now we have a strategy of examining the joint. We study joints under a few headings. One is that what type of joint it is. If you learn it in this way, it is very simple. This joint is also a plain synovial joint. What type of joint it is? It is a plain synovial joint. Now you can correlate. Sternoclavicular joint was also a plain synovial joint. So this is a plain synovial joint. If it is a plain synovial joint, how many degrees of freedom does it have? The same answer in the sternoclavicular joint, that is 3 degrees of freedom. So this one has 3 degrees of freedom, and that can be 3 rotatory, 3 translatory degrees of freedom. Am I right? Yes. And now we learn about the articular surfaces. What are the articular surfaces of acromioclavicular joint? We studied already. That is the acromion process of the scapula and lateral end of the clavicle. Here we need to specify, because it's not the entire acromion process that is going to articulate. It is a small facet in the acromion process. Can you visualize from this bone? Let me mark it with this color so it can be easy for you to visualize. See this one. This is a small facet in the acromion process which is going to articulate with the acromioclavicular joint with the lateral end of the clavicle, not the entire acromion process. So earlier we studied that it's an acromion of the scapula with the lateral end of the clavicle. Here we need to specify in depth, that is the lateral end of the clavicle articulates with a small facets in the acromion process of scapula. Right? Now what are the accessory structures? What are the accessory structures? The accessory structures includes, of course, the capsule is there. Now, does it has a disc? Yes, it has a disc is there. Then ligaments, of course, you know that these are the articular associated process or accessory structures. Right? Now, the last heading would be the motions. Of course, it has 3 rotatory motions which we will discuss in the next session. Right? Now, let us examine in detail about each of these categories. We know that the joint is a plain synovial joint. There is nothing more to explain on that. The degrees of freedom in a synovial joint is always triaxial. Therefore, it has 3 degrees of freedom. That is 3 rotatory and 3 translatory. What we need to focus is about the articulating surfaces. Articulating surface. We already saw that the articulating surface is between the acromion of the scapula with the lateral end of the clavicle. The acromion of the scapula, we got an important point over here, that is a small facet on the acromion. Not the entire acromion process, but a small facet on the acromion process. Don't miss it that. Don't miss that. Now, examine further, we see that contrary to every other joint in the human body, we have a peculiarity. These articular surfaces are vertically oriented. If, for example, if this is the glenohumeral joint, this is oriented like this, somewhat perpendicular or perpendicular to each other. If it is an elbow joint, it's a parallel. But here you can see that it's almost a vertical orientation. So it has the articulating surface which are mostly vertically oriented. That's a peculiarity over here. Vertically oriented articular surfaces. Articular surface. Why is that? That is because your clavicle is a horizontal bone. So this is how it's going to articulate, and these articular surfaces are vertically oriented to each other. But you should remember that this vertical orientation can differ from each individual. There can be almost a 16 to 36 degree variation between the individuals. There can be 16 to 36 degree of variation between individuals. That means it can vary from the vertical plane by 16 degree to 36 degree. Am I clear? If you have any problems with learning that point, just avoid that. It's simple. The acromioclavicular joint is a vertical joint, and vertical orientation may be 16 degree from the vertical plane. If this is the vertical axis, this would be 16 degree, or it would be 36 degree away from the vertical axis or vertical plane. Right? Am I clear? Yes. Now, we need to look further into the joint. We see that the joint is a plain joint, plain synovial joint. We already discovered that. Now the articular surfaces may be flat or concave convex. What is that? The articular surfaces, that is this articular surface in the lateral end of the clavicle, and this one would be mostly plain like this. So we call plain synovial joint, plain or flat. In some individuals, it may be reciprocally concave convex. That may be like there might be a concave one in the acromion, and in the clavicle there might be some convex shape. Or in the acromion itself, there may be a concave shaped facet and a convex shaped facet. In acromion, in clavicle, there would be a convex and a concave respectively. So it may be reciprocally concave convex, or concave convex, or convex concave. So the articular surfaces, we don't have a strict, or we don't have a correct estimation. It varies between the individuals. So this articular facet may be convex. For example, here you can see that it may be somewhat convex. So that is articulating in this concave shape. If you clearly observe this one, this is slightly concave, on concave. If in some other bone, if you take, it might be flat, or in some other bone, if you take, it might be reciprocally concave convex. And this makes the joint an incongruent one. This makes the joint an incongruent one. So acromioclavicular joint, like the sternoclavicular joint, is an incongruent joint. So that's the details about the acromioclavicular joint, articular surfaces. Now let us look into the accessory structures in the acromioclavicular joint. What are the accessory structures? First one that we have to discuss is always the disc in the acromioclavicular joint. The disc in the acromioclavicular joint. For example, if you had listened to the previous video, you would have noticed that we discussed the disc for about 10 minutes because that was very crucial structure with respect to the sternoclavicular joint. But here it does not have much as serious function, or it's not a very important part of the acromioclavicular joint. In fact, the disc shape vary between individuals. For example, my right side disc may be one shape and left side may be one shape, or it can vary between two individuals. Okay, for example, my disc in acromioclavicular joint might be slightly differ from my friend's acromioclavicular joint disc, or it might be even be different from my right and left side, or it would be different in my 30 years of age, and if I take an X-ray, or if I find out this one and with an MRI in after 60 years, it can differ. That means between the age as well as between in the individuals as well as between two individuals, the disc can vary in shape. That is acromioclavicular joint disc. The variation is it has a considerable variation in shape. It has a considerable variation in shape between different individuals. This is something that you need to remember about the acromioclavicular joint disc. Further, we also need to remember that at about 2 years of age, up to 2 years of age, the acromioclavicular joint is a fibrocartilaginous joint. It's a fibrocartilaginous joint. It's not it's a fibrocartilaginous joint, and after this 2 years, that means when we are doing the weight transfer activities and functional activities more, then this disc becomes or evolve as a meniscoid one. So the disc in acromioclavicular joint is a meniscoid shaped one, which is actually developing from the fibrocartilaginous joint surface. So the joint surface in an acromioclavicular joint, at the beginning it's a fibrocartilaginous, and later it becomes a meniscoid in shape after second years of life. That's all about the disc. Something it's not much relevant because it varies in shape between different individuals. When it varies in shape, the function of the disc also can vary, and it shows that it do not have a very serious functional significance. And now let us look into the other accessory structures. What are that? Let us look into the joint capsule. The joint capsule of acromioclavicular joint is a weak one. Therefore it is not having much significance. It's not having much significance. Whereas in sternoclavicular joint we saw that the disc is relatively stronger one, but here the disc is a weaker one. What you can do for examination point of view is that after finishing the sternoclavicular, acromioclavicular and glenohumeral joint, just make some charts, 3 columns, and compare this joints. Of course, scapulothoracic is not an anatomical joint, it's functional, so you don't have the structures like this in scapulothoracic. So you can compare 3 joints. If possible, it's better you compare sternoclavicular and acromioclavicular, then you can study many things. Whereas when it comes to the glenohumeral, there is some variations which you will learn later. So it's a weak one. It is not having much significance, except it is reinforced by ligaments. So it is reinforced by ligaments, and thus it gets some significance. Actually the capsule is weaker and it is not having much significance, but it has a reinforcement by the ligament. Especially which ligament? What is this joint? Acromioclavicular. So acromioclavicular ligament. The acromioclavicular ligament reinforces the disc and the capsule, and gives it some functional significance. Am I clear? So we have been discussing about the acromioclavicular joint, articular surfaces. About the disc we studied, the variations in the disc, and now about the joint capsule we studied. And now let us focus on to the next important structure in any joint, that is the ligaments. I know that when it comes to ligaments, many of you fear to learn it actually, but that is because you just by heart the ligaments. You can understand the motions, but you think that you cannot remember the names of ligaments, and you just learn you just by heart that one. That's not the way you should do. Actually, you should just look into the joint. Actually, you should just look into the joint. What type of joint it is? It is acromioclavicular joint. So first ligament over here is acromioclavicular ligament. What is that? It's so simple. In sternoclavicular joint, you had a sternoclavicular ligament. In acromioclavicular, you have acromioclavicular ligament. In glenohumeral joint, you have glenohumeral ligaments. So it's a simple. Actually, you don't have to worry about that. This is the acromioclavicular ligament. This is the first ligament. And what is the second ligament? What are the structures that are involved in this joint? You just have to look it down. This is the lateral end of the clavicle articulating with this acromion. So when both of these are connected together, you get acromioclavicular ligament. But there is additional structure known as the coracoid process, which is not articulating and directly to this joint. So this coracoid process will be joined to the clavicle, coracoclavicular ligament. So the next ligament will be coracoid process joining to the clavicle, that is the coracoclavicular ligament. So these are the two structures, two ligaments, whereas in sternoclavicular joint it was sternoclavicular ligament and the clavicle to their first strip, that is costoclavicular ligament. Always correlate like that and study, then it will be easy for you. Now let us look into the acromioclavicular ligament. The acromioclavicular ligament is made up of two fibers or two ligaments, that is a superior acromioclavicular ligament and inferior acromioclavicular ligament. What is that? It is made up of superior acromioclavicular ligament and inferior, whereas in sternoclavicular it was anterior sternoclavicular posterior. Here the joint is vertically oriented, so it will have a superior acromioclavicular ligament which is covering here, and here one inferior acromioclavicular ligament. So the joint has a superior acromioclavicular ligament. For example, just look at this diagram. If this is the acromion process, which is this the clavicle that is articulating to form the acromioclavicular joint, superiorly you have the acromioclavicular ligament, which is known as the superior acromioclavicular ligament. So this ligament is known as the superior acromioclavicular, and another one is known as the inferior acromioclavicular ligament. Now can you tell me what is the function of this ligament? You don't have to by heart, can you just imagine? So this ligament is actually helping the capsule to bring towards the both bones. You can imagine that if this ligament is not there, these bones may get separated from each other. So bringing together both this bone is brought to here and this one is brought to here, that function is provided by the acromioclavicular ligament. So the acromioclavicular ligament reinforces the capsule of the acromioclavicular joint in such a way that it helps in bringing together the both articular surface. That is a major function of acromioclavicular ligament. So what is that? It helps both of this one. It helps in bringing together or opposing the articular surfaces. That is a function. Articular surface, that is a function. And you must also remember that among this acromioclavicular ligament, that is a superior one and inferior, our superior one is very stronger. Can you imagine what is the reason? That is because you have the muscles like deltoid muscles aponeurosis, you have trapezius muscle aponeurosis, etc. emerging at this superior acromioclavicular ligament. So this aponeurotic fibers of this ligaments, muscles, or simply learn muscles, insertion of these muscles makes the superior acromioclavicular ligament much stronger when compared to inferior acromioclavicular ligament. Am I clear? So once again I can tell you that there is the insertion site and origin of which ligament muscles, the the deltoid and trapezius muscle. This is in fact the deltoid one, this is the trapezius one. So this muscle's aponeurotic fiber reinforces the superior acromioclavicular joint in particular. Am I right? Okay. Yes, and now we need to see the superior acromioclavicular ligament and the inferior acromioclavicular ligament has some more function, that it prevents the anterior translation by the superior directed forces. Of course, every joint has some superior directed force, inferior directed force, etc. So this superior directed forces will cause if the force is in this direction, superior directed, it might cause the anterior translation or anterior movement of this disc, of this joint. So this anterior movement of the joint is being prevented, or anterior translation is prevented by the superior and inferior acromioclavicular ligament. But you must note that it's not this ligaments that's going to prevent the superior translation or inferior translation or anterior. That is mostly done by the coracoclavicular ligament. You will learn it later. Okay, so basically this muscle or this ligament is also helping in preventing anterior movement of the lateral end of the clavicle, so that the anterior movement of this lateral end of the clavicle can be prevented by this muscle, this ligaments. Am I clear? Yes, I hope so. And now it's time that we learn to the another important ligament. This might be asked for you in your examinations, that is the coracoclavicular ligament. What is that ligament? Known as the coracoclavicular ligament. This is quite important because it has some diverse functions in the acromioclavicular ligament joint. The coracoclavicular ligament, you know that it's not going to be functionally the part of the joint, because coracoid process is not having any role in the acromioclavicular joint. Coracoid process is not having any role in the acromioclavicular joint, but this coracoid process can be linked together by this ligament, and hence this ligament do not have some functional significance in the acromioclavicular joint. It's not functional part. It's not a functional part of the joint. But this ligament is very crucial and is in fact made up of two bands or two portions. Can you say that? Can you tell me which is that portions? It is a conoid and a trapezoid ligament. What is that? A conoid and trapezoid ligament. It denotes the shape of that ligament. Let us see that the earlier example itself, if this is the acromion process. Okay, yes, fine. So this is the coracoid process and this is the clavicle. In fact, this total bundle of the ligaments that attach from here to here is known as the coracoclavicular ligament. This ligament in turn is having two bands or two portions. One is the conoid portion, which is like this, which is somewhat a cone shaped one or a triangular shaped one. So this is a triangular shaped one. It is located medial to the joint. This is the lateral end, this is the medial end. It is located medial to the joint. And next one, it is a quadrangular shaped ligament. You can see that it's a quadrangular shaped ligament like this. It's a quadrangular shaped ligament like this. When I draw into the fibers, you can see that I have drawn one like this, okay, and another one I draw like this. That means the conoid fibers are vertically oriented. What is that? It is vertically oriented. Whereas the trapezoid, what is this direction? This is the horizontal direction. The horizontally oriented fibers are seen in trapezoid ligament. So can you tell me the difference between conoid and trapezoid? The conoid is triangular in shape. It is medially oriented one. It is vertical fibers. It's having vertical fibers. Whereas the trapezoid ligament is horizontal in shape. It's in direction. It's a quadrangular in shape. What is its shape? It's a quadrangular in shape, and it is laterally located. And it is laterally located to the joint cavity. Clear? Now let us once again summarize that is a coracoclavicular ligament is made up of two bands, conoid and trapezoid. Now it's time that we look into the function served by this ligament, that is the conoid portion as well as trapezoid portion. So you have two portions, one is the conoid and trapezoid. So both of them will be serving different function. This conoid portion prevents or it acts as restriction to the inferior translations. Inferior translation of lateral end of the clavicle. So what is its function? Inferior translation. So this sort of movement, inferior movement, is in fact prevented by your conoid portion. Whereas the trapezoid one directs or prevents posteriorly oriented or posterior translations. posterior translation, because you know that this fibers differs in its direction. For example, this is vertically oriented, so it will prevent inferior translation. Whereas this one is laterally horizontally oriented. So due to this horizontal orientation, when the lateral end of the clavicle moves posteriorly, that posterior translation will be prevented by your conoid portion. Further, so you can imagine this one like this. So this inferior translation will be prevented by this ligament, whereas this posterior translation will be prevented by the trapezoid portion. Further, this ligaments is actually between the coracoid and this one. So it will prevent the upward rotation of scapula, or it will limit, not prevent, it will limit the upward rotation. So the it is attached to the coracoid to the clavicle. Therefore, it will have a limitation or limit the upward rotation of the scapula. When you study scapulothoracic joint, you will study the upward rotation and various other movements of the scapula. So this time, during the upward rotation, this ligament is going to restrict the upward rotation of scapula. So you have the conoid and trapezoid. There is nothing to confuse in this. This is preventing the inferior translation. Always remember, this is vertically oriented. Remember, this is horizontally oriented, though this will prevent posterior directed. Both are having the same function, that it will limit the upward translation. Upward rotation of scapula. Now, there is another role which, if you are interested, you can learn it. Like, for example, when there is a medially directed force. For example, when I am pushing over to this wall over here, I am exerting what sort of force? A force onto the wall, and wall is exerting a force onto me. This is medially directed, okay? This force will transmit or travel like this from the humerus into which one? This is in the glenoid fossa. Okay, into the glenoid fossa, and from the glenoid fossa it won't move to the acromion process, and from the acromion to the clavicle. It's not like that. It will move through the coracoid process. Our coracoclavicular ligament help in this transmission. So this force will be transmitted by the strong coracoclavicular ligament directly into the clavicle without moving through the acromion. Okay, the dissipation of the force. And what is the use of that? That will reach into the sternoclavicular joint, which is a very strong joint, and that forces will be dissipated. So this force dissipation strategy is another function served by coracoclavicular ligament. What is that? Can you understand? When there is a medially directed force from here to here, it is traveling like this with the direction of my pen. It reaches up to the glenoid fossa. From the glenoid fossa, it may move on to the bone of the acromion and reaches the acromioclavicular joint, and then it can go to the sternoclavicular. But what happens here? There is a direct connection between the clavicle and the scapula. That is the coracoclavicular ligament. If that ligament is not there, what should happen? It should move through the acromion process and to the acromioclavicular joint. What is the problem? Acromioclavicular joint is incongruent. It's not much strong capsule. It's not having much strong capsule, so it may go for dislocation, subluxation, etc. So what happens is that there is a strong connection directly between the scapula's coracoid process to the clavicle. That connection is known as which one? That is a coracoclavicular ligament. So that ligament will dissipate the force into the stronger sternoclavicular joint and its capsule and the ligaments. So that is the role, that is a force transmission role. So what are these roles? That is a inferior translation, posterior translation, upward rotation, then force transmission role. Force transmission or dissipation. You should explain that. It is when there is a medially directed forces, it passes through the glenoid fossa into the acromioclavicular joint, instead of into the acromioclavicular joint, directly through the coracoid process to the sternoclavicular joint. And finally, we have the shoulder is an integrated complex. You know that if there is an integrated complex, acromioclavicular, sternoclavicular, glenohumerus, scapulothoracic do not function alone. It comes into a unified manner. That's known as the integrated function. So in an integrated function of the shoulder, only one ligament or this ligament is having a very crucial role. That is your coracoclavicular ligament. What ligament? The coracoclavicular ligament is having a very particular role in the integrated function. Not the sternoclavicular, not the acromioclavicular, but the coracoclavicular ligament. What is that? Because it is attached to the scapula. It is attached to the scapula and to the clavicle. So what happens is that this posterior rotation of the scapula, you studied that yesterday, along with the rotation of the posterior rotation of the clavicle along with the rotation of the scapula. So this will be coupled. That means always there will be a link between scapular rotation and the rotation of which one? And the rotation of which one? The clavicle. Because if you imagine this joint is just having a superior capsule, just that only, and it's not into the cavity, or it is just a plain joint also, so it is incongruent. Here it is attached to the sternum but not attached to the scapula, so there is no other attachment actually. So what happens, the scapular rotation is there. For example, when arm is elevating, the scapula is rotating in the scapular plane. So that rotation of the scapula should be coupled with the rotation of clavicle. Clavicle and posteriorly rotate like this, can posterior rotate like this. So this posterior rotation should be coupled by scapular movement. That movement is provided by your coracoclavicular ligament. No need to confuse it. If you have any problem, just by heart that last point. That is, otherwise you will understand in the integrated function. In integrated function, you will see that scapular movement should be compensated or coupled with the acromioclavicular sternoclavicular joint. The acromioclavicular joint movements is been coupled because of the help of this coracoclavicular ligament, which is directly attaching the coracoid process to the clavicle. That is indirectly means it's attaching the scapula to the clavicle. Therefore, the rotation in both will be coupled together. That's all about the acromioclavicular joint. I know that you are waiting eagerly to know about the motions of acromioclavicular joint. We'll see in the next video. Until then, stay tuned. If you like the video, don't forget to click the like button and kindly subscribe to our channel.